Hey everybody, today we're going to start a series of videos that are going to cover some of the retro Mcas exams. My thinking is that the more exposure we have to these problems, the better off we're going to be. So I started with a 2015 exam, and a few disclaimers. One, the format of the questions in these previous exams are very different, but I still think it's worth seeing them because the content is comparable. It's just that the format of the questions and the difficulty is definitely increased with the newer next generation MCAS. But still, I think there's some value in seeing this stuff. So anyway, this is 2015. The PDF for this will be found in the video description. So if you, hold on, let me fix this. So if you want to follow along, obviously, the idea is that you try this on your own and then watch some of these videos to see how you did. Okay. The PDF actually has the answer key in the back, but this will show you how to do the actual problems and how to get the answers that they're asking you for. Okay. So we're going to start with session 1, which is the non-calculator session, which is right here. Okay. And all right, we're going to just go ahead and start. So it says the first 5 terms in a geometric sequence are shown below. So we have 4, 12, let me zoom in a little bit here. 4, 12, 36, 108, 324. So it's geometric, so it's not a constant rate of change. So I'm going to see what we're multiplying by here. So 4 times what is 12? 4 times 3 is 12. Okay. And 12 times 3 is 36. And 36 times 3 is 108. So you can see we're just multiplying by 3, each one. So the next term would be this times 3. So we're going to go 324 times 3. And that'd be 12, carry the 1s. 3 times 2 is 6, plus 1 is 7. 3 times 3 is 9. So 972 should be C. The next generation typically would not ask for the next term in the sequence, but maybe the, maybe the 7th or 8th term. Which would require you to use a formula or do it all out, but that's kind of like what I would see them doing in the next generation version. All right, number 2. Which of the following is equivalent to the expression below? So equivalent means equal value, right? So we have a polynomial here. We have x squared plus 7x minus 60, and they give us pairs of binomials. So there's a few ways to do this. One, you could factor this. If you remember how to factor, you could do it that way, or you could do process of elimination and just distribute each of these and see which one comes out to be this. We're going to start with the distribution and then we'll factor it. We'll do it both ways. Factoring is quicker, but if you don't remember how to do it, the distribution property would work just as well. Okay, so let's go ahead and distribute here. So x times x is x squared. X times negative 5 is negative 5x. 12 times x is 12x. And 12 times negative 5 is negative 60. And negative 5x plus 12 is 7x. Positive, and then x squared minus 60. So we already found our answer. If we do the rest of these, it's not going to work. We'll do a few of them. We'll do all of them. Why not? So we know it's going to be A. So B, let's try that. I'm going to rewrite that so we have more room. Let me zoom in a little bit. So x plus 10, and then x minus 6. So x times x is going to be x squared. X times negative 6 is negative 6x. 10 times x is positive 10x, and 10 times negative 6 is negative 60. Combine these together, you get 4x. Bring this down, a positive 4x, because take the sign of a larger number. X squared and negative 60. So clearly that's not the answer. So B's out. And then we'll do x plus 15. Some of you may remember this as FOIL. I'm not a huge fan of the acronym FOIL because it only works with binomials. As soon as you have a trinomial, the FOIL doesn't work. So we just I like to think of this as just a distribution. X times x is x squared. X times negative 4 is negative 4x. 15 times x is 15x. And then 15 times, I'm off the screen here. Hold on. Send it that way. And then 15 times negative 4 is going to be negative 60. Okay, so negative 4x plus 15x is going to be 11x. They're different signs, so big minus small, take the sign of a large number. That's not the answer either. And then the last one, D, x plus 20 times x minus 3. So x times x is x squared. X times negative 3 is negative 3x. 20 times x is 20x. And 20 times negative 3 is negative 60. So combine these together, you're going to get 17x. Bring down everything else. Okay. So you can see none of these work. So that's distribution. It just happened that A was our right answer, which made it a lot easier. If we try to factor it, we're going to look at this final number here. So we're going to, okay, here's x times x is those two right here. Look at the factors of 60. So we have 1 and 60. We'll write these out actually. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I think that's it. I think those are all the factors. Okay. So then we know it's a negative values, which means these are different signs. Because they're different signs, this is the difference. So which of these is a difference of 7? Well, it's 5 and 12 have a difference of 7, so it has to be those two. And then the larger one's positive, so the 12 would be positive. So plus 12 minus 7. That's just a quick and dirty way to do that. But honestly, I think you're probably better off just distributing here. It's much easier. Okay, number 3, so that's A. Circle A. All right, number 3. The length in centimeters of a rectangle is represented by the expression as shown in the diagram below. All right, so we have 2 plus the square root of 45, or radical 45. Based on the diagram, which of the following is closest to the length in centimeters of the rectangle? So they're asking us to estimate this radical, so it's 2 plus this. So let's look at what this would be close to. So we don't know the value of radical 45, but we can estimate it. Let's see what perfect squares it's in between. So radical 36 is 6, and radical 49 is 7. So radical 45 is somewhere in between those two values. Okay? And if I was to look at this, I know 45 is closer to 49 than 36. So we know it's in between 6 and 7, closer to 7. So right in the middle would be 6.5 or 6.5. So it's greater than 6.5 but less than 7. Right? So we had 2. Let's just do 6.5 to start. 6 and 5/10. So 2 plus that. Let's just call this, oh, I don't know. Call this 6.7. Just eyeballing it, right? So add that to 2. So 2.0 plus 6.7, you get 8.7. All right. Which actually, oh my gosh, I'm sorry. I keep zooming out. It actually turns out to be exactly one of the answers. It doesn't. I just happen to guess 6.7. Let's take a look at this though, or 6 and 7/10. We know that it's going to be greater than 6.5, right? And we're going to add 2 to it. So it's going to be 8 point something, right? So these are immediately out. Okay. 8.3 would mean it's closer to 6. So that's out. It has to be 8.7. Right? The key to solving these is really knowing your perfect squares and knowing where along the lines this is closest to. We know this is 9 away from that, but only 4 away from that, right? So 9 plus 36 is 45. 45 plus 4 is 49. So it's only 4 away from this. It's definitely closer to 7. This would be easier without the 2. A lot of people would struggle just because they'd forget about the 2. All right. So it should be B. Let's go ahead and take a look at number 4. Giselle surveyed 10 students at random about the number of people in their household and the number of times laundry is washed in their household each week. The results of her survey are shown in the table below. So we have this table here, number of people in the household, the number of washes. So you can see the x-axis here is number of people, and number of washes is the y-axis. Which of the following scatter plots best represents data in this table? So we're going to look for these values. So we have 2, 1, 3, 2, 2, 2, 3, 5, 6, 5, 5, 3, 1, 4, 6, 3, 3, 4, 3. Okay, so we're looking to see which of these graphs accurately depicts this. So we're just going to look point by point. So 2, 1. We're going to circle each one. 2, 1. Yep. 3, 2. 3, 2. Yep. 2, 2. So 2, 2. Yep. Let's check these off, actually. 3, 5. Yep. 6, 5. Yep. 5, 5. Yep. 3, 1. Yep. 4, 6. Yep. 3, 3. I think we lucked out here. No, we didn't. Oh, look, 3, 3 is missing. Wah, wah. 3, 3 is missing. And then 4, 3. So this one was looking really good, but it's missing this 1 point. So I'm pretty sure A is going to be out. Let's take a look at option B here. So 2, 1. Nope, it's already out. But this is already, yeah, let's say that one's already out. C. 2, 1. That's out. I'm assuming it's going to be this one. I can't remember. I haven't done this Mcas in a long time. It's interesting seeing these older problems. All right, 2, 1. Yep. 3, 2. Yep. 2, 2. Yep. I'll check down here. 3, 5. Yep. 6, 5. Yep. 5, 5. Yep. 3, 1. Yep. 4, 6. Yep. 3, 3. Yep. And 4, 3. Okay, so that's the winner right there. Winner, chicken dinner. That's an interesting problem. So some of the more recent MCAS problems, they give you a scatter plot, and you have to do a line of best fit, or you have to plot out a scatter plot and do a line of best fit. I haven't seen one like this in a while. All right, number 5. Which is the value of the expression below? This is order of operations right here. So just as a reminder, parentheses, exponent, then multiplication, division, a single step from left to right, and addition, subtraction, a single step from left to right. All right, so we have parentheses? We sure do. Let's do the work in the parentheses. So 5 plus 4 is 9 squared. We have working parentheses here, and exponents comes first, so 4 times itself is 16. So 5 plus 16. And then 5 plus 16 is 21. And let's see, 9 squared. So 9 squared is going to be 81. And that's going to be 60. Okay. I'm trying to think where this is going to trick people. Some people would actually distribute that too, which they're not supposed to do, but I've seen people do that. I'm trying to think where else there'd be problem errors. Some folks would add the 5 and the 4 before they use the exponent. They get 9, which would make this 81, which is obviously going to be wrong. Those are the areas I could see people making a mistake on. Number 6. What are the solutions to the equation below? So there's a few ways to solve this. One, you can plug these in, or you can kind of mental math this. Let's just think this logically. Let's mental math this first. So we know this times this equals 0, which means one of these values, one of these binomials, has to equal 0. So then you say to yourself, okay, how do I make this binomial equal 0? Well, x minus 2. If x minus 2 equals 0, that means x would have to be 2. So if this was 2, right, 2 minus 2 is 0. 0 times anything is 0. So that's one way. X could be equal to 2. Here, x could be equal to negative 9. Because if you plug it in, you're going to get 0, and 0 times that is 0. So it's going to be C. But let's say you didn't know how to do that. Let's say you're like, Mr. Edwards, that doesn't make sense. No big deal. Just plug these in. So go ahead and plug these in. So negative 2 goes in here, so negative 2 minus 2. And then negative 2 plus 9 equals 0. You're going to get negative 4. And then 7. And then negative 20 equals 0, which is obviously wrong. So this one is off, right? So that's out. Negative 2, we know that's out because we tried that one. It's obviously going to be 2 and negative 9, but let's see. You would plug these in, you'd get a true answer. Let's just do it. Why not? So 2 minus 2, and then 2 plus 9 equals 0. Well, yep, 0 times, was that 11? And then 0 times 11 is 0, so that works. Well, let's just say we didn't do that. Plug in 9 here. Let's plug that in. So we're going to plug it in here so I have more room here. 9 minus 2 times 9 plus 9 equals 0. We're going to get 7 times 18. What's 7 times 18? 6, carry the 5, 26, I think. And that's wrong, obviously. So C would be the answer. So it's probably easier to plug it in if you don't know how to just plug, mental math that. But if you can mental math that, it's a really quick and easy problem. All right. This will be the last one for this video. So number 7. The line plot below shows fuel efficiency in miles per gallon for the vehicles owned by a rental car company. So each of these X's represents a single vehicle and their fuel efficiency. Based on the line plot, what is the median? That's the word we're looking for. Median fuel efficiency in miles per gallon of the vehicle. So for this problem, you need to know what median means, which is middle number. You remember this when you learned mean, median, mode, and range, right? All right, so let's go ahead and do this. So we're going to write these out, actually. So 27. There's a few different ways to do this. I'm going to do what I think is the easiest way for most folks. 29. Each of these is a number, so 29, 31. There's 3 32s. 32, 32, 32, 33, 34, 35, 2 37s, 39, 40, and 43. And we're simply going to go high, low, high, low. So low, high, low, high, low, high, low, high, low, high, low, high, low, high. So our middle number is 33. You could also do it this way. It's already set up for you. You could say low, high, low, Oh, I didn't even see, I'm so sorry. Gosh. I definitely haven't done these in a while. You can tell my camera work is not great. So low, high, low, high. And you can do it this way, right? Low, high, low, high, low, high, low, high, middle number. So if you don't want to write the numbers out, you can do it that way too. All right, so we're going to stop it there. Hopefully that was helpful. Let me know if you have any questions. Or actually, let's just check our answers. Make sure we did it right. Hold on. So, because we have the answer key, might as well just check it. And I didn't do this ahead of time, so let's see how we did. So if you check this chart here, we can see. So 1, we got C. Yep. 2, we got A. Yep. And this actually shows you the old standard, which is interesting, old 2000 standards, the old ones, which isn't really that helpful, I guess. B for 3. Yep. 4, we got D. Yep. 5, we got C. Yep. 6, we got C. Yep. 7, we got B. There we go. So we got them all right. All right, so guys, let me know if you have any questions. I'll make a few more of these when I get a chance. Thanks.